In this video we will be discussing angles of elevation with regards to a particular question which I've called example 4. A 23-metre lighthouse sits atop a 35-metre cliff to assist ships in navigating at night. A sailor at sea notices the angle of elevation to the lighthouse, that's the top of the lighthouse, to be 1.33 degrees. How far is the sailor from the base of the cliff? I've also noted here with brackets to assume that the lighthouse rests on the edge of the cliff and the sailor is at sea level. Now the first thing, the most important part of this question I feel is creating an illustration or a diagram to represent the information in the question. So what I've gone and done is exactly that. What I have drawn here is my lighthouse, which is resting atop this cliff. The lighthouse is 23 metres, the cliff is 35 metres. Okay, the height of the cliff we're suggesting is the height above sea level. Okay, so there's the ocean or sea level, that's why we have a bit of a wavy line there, and I've suggested that that's the ocean. I've also put in the angle of elevation from the sailor to the top of the lighthouse, the angle of elevation being this angle here, from sea level to the top of the lighthouse, to be 1.33 degrees. Alright, now to start this problem, the first thing that we need to identify is a right angled triangle. Now I guess we also have to assume another thing, that is, with regards to this assumption, another assumption we need to make is that this cliff and the lighthouse are perpendicular with sea level. Okay, that is that they form a 90-degree angle, like so. And assuming the building was built correctly, you'd hope that it was standing straight, so that's another assumption that we're going to make. So there's my right angle, which means that I can either use trigonometry or Pythagoras depending upon the information that's provided to answer this question. Because I'm given an angle, it's likely that I'm going to have to use trigonometry. Now because I'm going to likely have to use trigonometry, I'm going to label the sides of this right angled triangle with regards to the sides that we see in the trigonometric ratios. If this is our angle in question, the opposite side occurs opposite that unknown angle, or that known angle even, which is the 1.33, which is why this is our opposite side. The hypotenuse always occurs opposite the right angle, this side here, which I've labelled H, leaving our adjacent side meaning next to the angle. The question is asking us to determine how far the sailor is from the base of the cliff, which I've labelled as this distance x. Okay? Now once we've got the image, it's not too difficult to apply a trigonometric ratio to solve for x. And if we were given a triangle with an angle and two values, or an angle and one value, we could calculate for either of those unknown sides, which is what we're going to do. Now the only other difficult thing that we might have to notice or recognise is that these two values here represent this entire side. So the sum of these two values will be the total distance from the top of the lighthouse to sea level. So the distance in total is not 23 nor is it 35, it is actually 23 plus 35. Okay, so let's start this problem. I'm applying my tan ratio because the side that I'm interested in is the adjacent side x, A, and the only other side that I actually have is O, which, as I just previously stated, is the sum of these two sides. Once we've got our trigonometric ratio, we need to substitute, which is what I have done here. I've substituted in 1.33 for the angle theta. I've substituted in the opposite side, which, as I said, is the sum of these two numbers, meaning we have to add these two numbers, so 23 plus 35. Okay, so sum of. I then divide it by the adjacent side, which is my unknown x. If I simplify this numerator, I get 58, and then it's just a matter of rearranging to solve for x. So to do that, I'm going to move x to the other side by multiplying. which will leave my 58 on the right hand side. Then what I want to do is move the tan 1.33 to the other side so that I've just got x remaining on the left. So to remove this from this side I have to divide tan 1.33. What I do to one side I must do to the other, therefore I have to divide 58 by tan 1.33 to get my x. Therefore x equals 58 divided by tan 1.33. In a calculator will give you the value in metres, because all the other units we used up here were in metres, which I rounded to 2.5 kilometres, which this suggests an approximation.